Hello everyone, I am Anjali Hiramat from Sri Siddheshwar Women's College of Engineering Solapur, second year B Division of Computer Science Department. Today we are diving into a very important topic in design and analysis of algorithm, that is recursive call. Let's start. Recursive calls, design and analysis of algorithm. This presentation explores recursive calls, a powerful programming technique. We will cover their design, analysis, and practical applications in algorithms. What is a recursive call? Recursive call is when a function calls itself in order to solve a problem. A recursive call happens inside a function when the function calls itself with a different input, helping to break a big problem into smaller subproblems. Why use recursion? Recursion is useful for problems that can be divided into similar subproblems like factorial, Fibonacci, tree or graph transversal. It involves nested or structures like file, system or expressions. What are the benefits of recursive calls? Benefits of recursive call is it simplifies complex problems. Recursion can break down complex problems into simpler subproblems. For example, traversing a tree or solving a maze is easier than recursion than loops. Cleaner and shorter code. Recursive solutions are often shorter and more readable than iterative loop-based versions. For example, computing factorials, Fibonacci numbers or power of a number become 2 to 3 lines. Works naturally with hierarchical structure, ideal for tree or graph data structures where each node may contain subnodes. For example, file system navigation, DOM parsing in HTML or design trees. And it is also benefits for mathematical problems fit naturally. Recursion aligns well with mathematical definitions like factorial of n is equal to n into factorial of n minus 1. Fibonacci of n is equal to Fibonacci n minus 1 plus Fibonacci n minus 2. It is useful for backtracking, essential for backtracking algorithms like Sudoku solver, n-Queen's problems, permutations and combination. It is also easier to prove correctness. Recursion functions can often be proven correct using mathematical induction, making them great for theory-heavy problems. Base case and recursion case. What is the base case? The base case is the condition under which the recursion stops. It prevents infinite recursion by not calling the functions again. The purpose of base case is it acts as the exit or stopping condition and it tells the function, stop, I can solve this directly. Recursion case. What is recursion case? The recursion case is where the function calls itself with a smaller or simpler input. What is the purpose of recursive case? It moves the problems closer to the base case and it breaks down and the larger problem into smaller parts. Analyzing recursive algorithms. Substitution method, recursive tree method and master theorem. In the substitution method, guessing a solution then proving it by induction and it verifying a subset upper bound. Recursion tree method, drawing a tree to visualize recursive calls and cost and it generating good guesses for the substitution method. In master theorem, a formula for solving recursions relation of a specific form and it quickly solving common recursions. Efficiency consideration. In efficiency consideration, stack flow. What is a stack flow? Each recursive call uses a stack frame. If recursion goes too deep, the stack memory limit is exceeded, causing a stack overflow, error, or crash. Redundant computation. What is it? Some functions calls are computed again and again in naive recursion. It occurs in Fibonacci sequence combinations or binomial coefficient game tree evolutions. Second is memoization. Memoization is storing the results of expensive recursive calls and recurring when the same inputs occurs again. Why it matters? It matters to prevent redundant computation, especially in overlapping subproblems. For example, Fibonacci. Third is iterative versus recursion. Recursion is a code clarity shorter than elegant, and its memory uses is more, and its performance can be slower. The tall call optimize depends on language, and it is used for tree, divide, conquer, and backtracking. Iterations, code clarity sometimes longer, and memory uses less. It performance often faster. Tall call optimization always space efficiency, and iteration used for loops arrays simple tasks. Example and applications of recursive call. It is used in factorial, Fibonacci sequence, tree transverse, and sorting algorithms. Sorting algorithms in merge sort and quick sort use recursion efficiently. In tree transversal, pre-order, in-order, and post-order transversal. In Fibonacci sequences, each number in the sum of the two preceding ones. Thank you.